Hello everyone, I'm Jason Sikes, aka the Tech Rancher, and here's my homework solution for lesson number 36 by Paul McWhorter. Paul does multiple different types of electronic training courses with different types of courses too. You can find him on YouTube at Paul McWhorter, or on his website. You can find more information at www.toptechboy.com. Check him out, let him know I sent you. Alright, enough about promoting Paul. Let's look at somewhat what the homework was. As you can see behind me here is the layout for the wiring diagram. I could not find an SSD 1306 for the CAD 7. So we're just going to do the wiring diagram, and that would be pretty close. You should be able to figure out how to do schematics from the wiring diagram itself. So let's take a look at this real quick, and then we'll look at the homework solution, and then we'll look at the code. So I'm going to pull myself down here a little bit. Oh, it cut my head off a little bit. Okay, Raspberry Pi Pico W right here, and you can see the green one up here is coming up to the ground rail, the top ground rail. And then we have a red coming over from the other side, which is a 3.3 coming to the top ground rail, or to the top power rail. And then let's go ahead and continue on in the rails. Pin number 40 right up here is coming down. This is 5 volts coming off of the USB port. That's the only time you'll get that out is if you have connection to the USB port. Unless you have an external power supply, but that's the only thing you're going to be able to do. If you just hook up a regular power supply to the Pico W, you're only going to get 3.3 coming out. You're not going to be able to get 5. If you're going to run a servo that's going to require anything larger than 3.3, which probably 99% of the time you're going to have to, you're going to have an external power supply that runs just for the server. And then you're going to connect your ground from your server to the ground of the Pico W to keep it within the same loop of the ground. But then continue back on what we're doing here. We have ground on the left side or right side, depending on how you look at the Pico W, coming to the ground rail on the bottom rail. This is feeding to our servo that you can see kind of slightly over here. Oops. Oh, I didn't mean to do that. I meant to grab it. Yeah, as you can see, here's a representation of our servo. Let's continue on with our layouts here. Then we have, this is pin number 28. It's coming up and coming all the way over here to the potentiometer. This is going to be, because it's a analog to digital conversion pin, so that's why we're going to run it over here to the potentiometer from the other side to the potentiometer. And then I decided, which wasn't a requirement for the homework lesson, but I decided to go ahead and add in an SSD 1306. I'm displaying what the degrees of that the server is doing to being displayed on the screen. So let's hook that up here. So for our SDA, we're running off of pin number 7. And then for our SCL, we're running off of pin number 6. Correction, that's actually pin, but not the GPO. GPO would be pin 4 and pin 5 for GPO. GPIO, sorry. And then we're connecting to the ground off the top rail and power off the top rail. Back over to the potentiometer and grabbing power from the top rail and then ground from the rail right below that. And now let's go over here and look at the servo to connect up the servo. Red would be our power supply, which is the 5 volts running into the servo. And then we have ground connecting to the ground rail. And then we need to be able to run our data. And so we're using GPIO pin 15 coming down over here for the data of the servo to be able to communicate to the servo. A servo runs off of a pulse width modulated PWM, pulse width modulator. There we go. And it runs off the width of a 20-second or millisecond cycle. So to be able to get, I wish I had this written down, but I'm just going to have to talk to you about it, and you're going to try to think about it in your head. Grab a piece of paper and write it down while I'm talking. There you go. If you do a 0.5 milliseconds, that is indication of 0. If we do the total of 20 milliseconds, we're telling it 180 degrees is what we want. Or no, sorry, 2.5 milliseconds. We're saying turn to 180 degrees, and then it has a cycle of 20 milliseconds. Which, when we set this up to be able to tell our code how to use it, we're going to specify by frequency. So 1 over 20 for milliseconds can be converted to 50 hertz. So that's the cycling that we're going to use. And now let's get this going. I'm going to pop myself back up here a little bit better where you can see me a little bit better. Hey, there we go. And I'm going to pull up. There it is. And then I am going to come over here and behind us. Hey, now we're getting it. Now we're getting it. And I'm going to activate our code down here. I always keep on hitting the wrong screen here. Okay, I'm starting it. And you can see from the display. Let me move this over here a little bit more, and I want you to try to be able to see the display so you can see the printout here. And I'm using the camera's focus this time instead of my focus, and I don't like it as well. Bear with me here as I go to manual focusing. I just feel like I can get with a manual focus, you can be able to read it better with me being able to manual focus because I specify where I want to focus it. Alright, enough of that. Let's get this going here. Here's my potentiometer, my fingers on the potentiometer, and you can see my hand. You can see the degrees, and if I start turning this, which, two hands. Let me scoot over here. Alright, and I want you to be able to read this, so I gotta move this around here. You can read, and now it's blurry. Hang in there with me, y'all. I apologize. And I think we're just making it more blurry. I can't tell. Oh boy. Oh, there we go. That's really bad. Okay. Ooh, this thing is touchy. Hey, now we can start reading it. Okay, now let's start turning it. I'm going to turn the potentiometer, and you'll see that the servo is moving at the same time. And you can see the degrees are being displayed on the SSD. And it's representing where we are located at. And as we keep on turning it, and there's 0, and we turn it back, and you can see the degrees being displayed on the screen. And as we turn the potentiometer, it's moving, and there we go. And there it says 80, and that's full over. Alright, now let's get back over here and look at the code. I'm going to close that little window out. We're done with that, and I'm going to enlarge this so we can see, everyone can see. How about that? I'm gonna come over here and there we go. Okay, and I'm gonna pull this one down because we really don't need to see that right now. Homework solution for number 38, or sorry, 36. I'm rushing things here. And sorry, I gotta reposition the mic. Okay, we're importing our libraries. I like to import const because I don't want anything to change on our pinouts. So that's through MicroPython. And then we're importing machine pulse width modulating pin I2C import enter. Okay, anyways, I2C and then ADC. And then, which is already on our Pico W in the library well, let's see here, I have to stop that first. And then, so we got it in our library of the SSD 1306, importing that. So we're saying we're going to use the class of SSD 1306 underscore I2C. We're importing utime as time, and we're bringing in our variables. We're declaring our pins. Our servo pin is GPIO pin 15. I think that's what I told you on our layout a while ago. Pot pin, which is a potentiometer, 28, which we had to go across the board for that one. And then our SDA pin is GPIO pin 4, and GPIO pin 5 is a SCL. And then our I2C frequency is 400,000. And then I'm going ahead and specifying our screen width and height, 128 and 64, to be able to start that object. Now we'll come down here and create the object of I2C. We're using the class of I2C that we brought in from a machine. And then we specify that we're using group 0. If you use pin 4 and 5 on a Pico W, it's group 0. See, 6 and 7 is group 1. And then the SEL pin, we're using our pin that we specified up here. And same thing with our SDA pin, same thing that we set up here already. And then our frequency that we set. Then we're bringing in and we're using that object into our class. And so we're saying we're giving it the class name or of an object of DSP, and then using the SSD 1306 I2C class, which is already stored in our Pico W, and we're bringing in the width and height of our display along with the object that we created right above it, which is I2C. The servo is a pulse width modulating, bringing in the pin and the servo pin, and then we're setting the frequency to 51. I know if you round it is 50, but I was playing with it and I just now realized I never changed that out of it. So I still have it 51, but it worked just fine. The reason why was because I was doing it and adding in the float value, which was actually 51.0 something, which technically you could use 50 or 51. I did both of them and really didn't make a difference at all. So I for some reason I left it at 51. Anyway, and then we're declaring a duty cycle. This is turning it on, but with nothing in there, so it's actually not doing anything. We're just specifying it for the duty because we're going to be using it down here a little bit later. Creating our function of read the pot, which is a potentiometer, and we're adding into the pin, and then we're returning the pin.read and then the uninitialized 16 with nothing in there, but we're going to be calling that here in a little bit. And then we did a try and accept. Within that, we're doing our while true. We're clearing our screen because we're using that SSD, and then we're grabbing the potentiometer value by calling in that function of read pot, adding in our my pot, which is the object that we create up here. And then we receive that data back, and we're going to use it right here in our formula. Here's where we start the math. Yay, math! Okay, we had to do an int because it turns out to be a float, so we're going to call it into an integer because it doesn't work otherwise. And our slope and point slope is the formulas that we used. I'm sure a lot of people are used to this. If you're new here, Paul does multiple because it's something very important. Is to learn the slope and point slope. But let me give you a breakdown what that formula is. It's y2 minus y1 over x2 minus x1. That equals m, which would be the representation of our slope. Now we need the point slope value to be able to specify anywhere within 2 points. We're going to start from 2 points and we want a value within those 2 points. That is our point slope formula is going to be able to do that. That formula is y minus y1 equals m, which is the value that we got from the slope or the line slope, times x minus x1, and then x and y are going to be specified as what we want for x and xy. Oops, sorry. And then see here for y, for our first one right here, for our angle is going to be our y. The angle value is going to be the y, and the x is our pot val, which is the value that we got here to read from our potentiometer. Can't talk. Now we're doing the information and the value stored in here for the servo. In order to do this, now we need to come up with a variable, and I did write val because I was writing this down as Paul was describing about it on 36. Paul did this one right here for us on 36. I'm just going to repeat it here what Paul did. And we take then we take this right here. We're taking the y2 minus y1 over x2 minus x1, which gets us our m, and so that's what we did here with Paul. And so we have 6553 over 180 times the angle, which is the angle that we did right above it. Then we're plus, because this is our x1, and our x1 value was 1638. This is the information we'll take from this, and we're going to put it into our servo, which servo right down here to write into our servo to turn the angle. And then I did my messaging that I did on my display. I'm adding in, the servo angle, sending that to the screen, and did our message angle, which is adding into degrees of what we did, which is just grabbing the variable of angle and putting it in there, and then having that display onto the screen, and did a sleep of 100 milliseconds. I was trying to minimize the amount of bouncing that the servo is doing, but if I did anything greater than 100, it tends to do a lot of delay, and it causes the servo arm to jerk quite a bit to catch up. So 100 is about as good as I could. I went a little bit less, but then it doesn't really minimize the bouncing that it's doing, because it's reading so fast. And using a potentiometer is not the best reading a tool for that, for a servo on that aspect. It needs to have a little bit more bounce delay in between that. Anyway, and then on accept, keyboard interrupt, it's just going to clear our SSD screen. Well, y'all, that's pretty much about it. That breaks it down. I hope you enjoyed it. Until next time, be safe out there.